Okay, well, hi everybody, and welcome to today's webinar. This is multifunctional stormwater design with vegetated systems and native plants that work. This is a three-part online series for low-impact development, and we'd like to thank our sponsors for today's webinar, including the US EPA, Arkansas Department of Agriculture Division of Natural Resources, Beaver Water District, Construction EcoServices, and Craft and Toll. For those of you just joining, all right, so for those of you just joining, I'm your host, Becky Rowark, Program Director for Beaver Watershed Alliance, and we have two guest speakers today, Anthony Kendrick, Project Manager with Construction EcoServices, and Eric Fuselier, Environmental Project Manager with Craft and Toll out of Rogers, Arkansas. Just a few housekeeping notes for engaging with us during this presentation today. At the bottom of your screen, or somewhere on your screen, you'll see a Q&A bubble. You can click on that and ask questions. Feel free to ask questions anytime, or there's also a chat function too, where all attendees can see those questions, and we'll just answer these as we go along. This webinar is also will be recorded and is available on demand. So if you missed something or you need to go back and reference something, that is available after today's program, and we can send you a link. We want to thank all of you for participating in today's online event. And also, if you would like a certificate of completion for professional development hours, just please email us afterwards and we can get that for you. So with that, I'm going to start us off with a little bit about the Beaver Watershed Alliance and our work here in the Northwest Arkansas area. The Alliance is a nonprofit, and we are located in Northwest Arkansas. Our headquarters are in Springdale, Arkansas. Right now they're at home, but that's where we usually are. And our mission is to proactively protect, enhance, and sustain water quality in Beaver Lake and the integrity of its watershed. We accomplish our mission throughout the entire watershed area through a variety of activities in working with thousands of volunteers and landowners each year. We implement best management practices in urban areas and on the farm, all to improve water quality. We also work with a number of partner agencies to conduct scientific analysis and research within this watershed to learn water quality trends and to help prioritize our work. Just a little bit about us. So here we're looking at the White River watershed area. The shaded, kind of light shaded zone around the blue area is all the White River watershed. And watersheds are defined by topography, and they basically act like a big bathtub. They're all draining rainfall to a certain point in an area. So in this case, the White River is all draining to the Mississippi River over in eastern Arkansas, which flows down all the way to the Gulf of Mexico. The White River, the Beaver Lake watershed is in the headwaters of the White River system, and it's also one of 3 impoundments that were built for flood control back in the 1960s. So today, Beaver Lake serves as our primary drinking water source for 1 in 6 Arkansans. It provides hydroelectric power. It brings in millions in recreation and tourism. It's become a cornerstone of economic growth in our region. Last we checked, there was about 30 people moving to Northwest Arkansas per day, and our population is encroaching, if not surpassing, about 500,000 residents here. So Beaver Lake watershed is a state priority watershed with tributaries that are listed on the 303D list that do not meet their designated use. There are currently 5 stream reaches that are listed as impaired. And part of that impairment is caused by sediment. It is the #1 source of pollution in this watershed. Stream bank erosion is currently the highest contributor to sediment. Urban runoff and dirt roads also contribute. Low density development and loss of pasture land and forests is expected to have a greater contribution to sediment loads as we grow in this region, particularly in the western portions of the watershed. So that's why it's really important for us to focus on reducing rain runoff. Anytime we can slow down the rain, soak it in on site, decentralize it, or use nature and design to build and accommodate the stormwater, we can prevent or reduce these environmental impacts downstream. So a lot of communities are seeing the value of green infrastructure and LID as a way to solve water problems, especially ways to handle these more intense rainfalls we're having. We used to get 3 inches over a 24-hour period. Now we're getting 3 inches in an hour. So we're seeing extreme intensities of rainfall here in the Northwest Arkansas region that we've heard all over the United States are facing similar challenges. So how do we deal with that water? Where is it going? How can we keep it on site? With all green infrastructure and low impact development can help do that. Back in 2017, the Alliance applied for and was awarded this green infrastructure grant. And this is basically to install 3 LID parking lots throughout our watershed area. We have one going in an urban park, one at the boat launch around Beaver Lake, and there's an LID parking lot going in at a rural community park. And both Anthony and Eric have supported these projects through their work and expertise. So we're going to get to hear more from them on that later. So this online series that we're having today is part of this grant to provide education and technical training for low impact development. We also want to thank our many partners of the Beaver Watershed Alliance. We're a small organization, but we're really proud of the level of support of our community, state, and federal program partners that really work together to help protect and conserve our natural resources. So with that, I'm going to hand this over to Anthony Kendrick, and he is going to talk all about our vegetated structures.
All right, well, thank you very much, Becky. I'll go ahead and switch over. All right, guys, so today we're going to talk about how we can really take advantage of our vegetated best management practices, whether it's a bioretention system, bioswale, infiltration trench. There's many different applications of using vegetation for stormwater management, and we'll go through that today. So a lot of times when you think about the value or the function of a vegetated system, the first thing that's going to come up is water quality. That's probably one of the first, motivations to start using, bioretention and rain gardens, was that they provided a good water quality benefit to your design. But what we really found over the years is that it could do so much more. So you can get your conveyance out of it. So rather than just using storm drainage pipe, well, we can use a bioswale. And then when it comes to surface detention, especially in Texas, where we do a lot of our projects, you get a lot of your site ends up getting allocated to a surface pond or a detention pond, and that can kind of eat up some of your real estate. And so what we found is that you can actually kind of maximize your lot yield by incorporating some of these vegetated systems like bioswales and bioretention. And then in some areas where we can promote infiltration, where we have soils that do drain, infiltration is a very good benefit, especially with groundwater recharge. That's actually one of the goals in New Orleans, is they're trying to implement green infrastructure so that they can kind of help recharge their groundwater to fight subsidence. And then of course, your vegetation and your plants, a lot of people see them as aesthetic features, which is a good benefit. And then also you got the urban heat island effect. So we'll show a project later on about using tree cells and making sure your trees reach full maturity, so you can kind of reduce the amount of sun that hits the pavement. And then lastly, you get your recreational value out of it, where where you're doubling your bioretention, bioswale, whatever it is, as a recreational. And then the question, how do you define bioswale? Generally, when I talk about a bioswale, it's more of a bioretention or a rain garden that helps convey water. So it'll generally be sloped, and it'll allow water to convey from one point, maybe an upstream point, down to either your overflow or where your engineered soil is. So typically when I think of bioswale, I think of just a vegetated system that helps move water. So I'm going to go through some of the design, construction, and maintenance issues that you see with these types of BMPs, and then we'll go through some case studies. And so whenever we work with either engineers or owners and they're looking at implementing this type of feature, the first thing we want to talk about is maintenance. And when it comes to vegetated systems, plant selection is really crucial. Sometimes they'll want a lot of native plants, or they'll want a lot of a very extensive planting plan. And if the owner's not prepared for maintenance, then that can be a burden on them. And so you can make maintenance simple. So here's a car lot where they incorporated a bioswale on the frontage side. So the first thing you see when you drive by on the service road. And they kept maintenance pretty simple. You can see they do have plants up on the hillside, and down there next to the overflow structure, that's actually where the bioretention, the engineered soil is. But if you look throughout most of the swale, it's actually just grass. So really for this owner, which is a car dealership, they're really just mowing, picking up trash, and then they have some small areas where they have to maintain. So this is just another unique, simple way of minimizing the maintenance. And that's important also because we want to make sure these owners have something they can maintain, so it's ensuring that it's working, because you don't maintain it, ends up going into bypass mode, and the water doesn't infiltrate as well. Now you can have more extensive planting. This is a park project where they use a lot of this horsetail reed and some other plants, and it's a little more maintenance intensive. Of course, this one, I think they kind of let it kind of grow wild, but this parks projects, they want to really highlight plants and their use. So these types of projects are really fun to work on. And then also we've done a lot of these roadside planters, especially with in the roadway development, because I think this is probably more a really good value when it comes to multifunctional systems, because on this project, they actually were able to reduce some of the pipe size of the roadway by using surface detention in the planters, or stormwater planters, whatever you want to call them. But it is a little more maintenance intensive. As you can see, there's quite a bit drop off the road, so this thing does store a lot of water. So it's going to bring in a lot of trash, debris, sediment into the system. So it does require more frequent maintenance than a simple swale with grass. And so this can be a little more maintenance intensive, but the value that the city and the neighborhood got out of it really boasted well, because they were able to get more businesses to come in here, because they made a more livable, walkable environment that attracted more visitors. So we have another question. So bioswale is just a ditch, not with engineered infiltration trench with select media. So I think a bioswale can be with your engineered soil, or it can be without it, just depending on how you do your design. So I think it kind of goes both ways. And then also you got your bioretention systems, where they like to use rock as an infiltration surface. So you can see here the plants are kept up high on the slope, and then they use rock in the bottom of the swale or the bioretention system. And what's good about these is eventually what's going to happen is you're going to get a lot of sediment and debris, grass clippings that get into that rock. And I'd imagine probably 3 or 4 years down the road, what's going to happen is it'll just turn into a vegetated system on top of that rock. So these work well in terms of maintenance, but as long as they know that rock bed, if they want to keep it with clean rock on top, it will require a little more maintenance than just your standard mowing and regime. Now, when it comes to bioretention, rain gardens, a lot of times you'll see a mulch layer on top. So the mulch layer, I like using mulch when you are going to infiltrate soil into engineered soil. So say you want to drain water into a subsurface drain. Always good to have a mulch layer sitting on top of your engineered soil. And the reason it is, it's almost like a sacrificial layer. So here's a project where the actual footprint of the engineered soil is roughly what you see here on this red mark that I called out. But they had some issues where we had some erosion. It basically carried a bunch of sediment and it clogged the mulch. But what's really good about that is it didn't actually clog the engineered soil. So mulch is very cheap. It's easy to maintain. So what you can do is you can actually just go dig up all the mulch that's clogged with sediment. You can expose the engineered soil and then put back a new fresh layer. So it's almost like changing out your filter in a car or home. And so this is a pretty simple maintenance method, and it really ensures that that system doesn't clog from erosion. And we'll figure out later on that erosion is probably the number one killer of vegetative systems when your slopes start to rill out and just carry loads of sediment in there. And then we got some other questions. So what is engineered soil? So I would say engineered soil is a type of soil blend that meets certain water quality and infiltration specifications. So typically engineered soil will have an infiltration rate that is specified, and it will also be able to provide some type of water quality benefit. So generally it removes about your total suspended solids, your oil and grease. So, but it's also a loosely defined term. If you blend up sand and compost together, technically that's engineered soil. So it's a pretty broad term, but when I refer to as engineered soil, I'm referring to something that has a specific criteria for drainage and water quality. And here's a really good example. We had a bioretention system that pretty much went unmaintained for years, and they had some erosion deposit, some sediment on top of the mulch. And then pretty much a new layer of soil was generated, and grass and weeds started growing on it. And so if you look closely, there's about 4 inches of just sediment and dirt clogging. And then below that 4 inches, it's kind of hard to see, but you can kind of see that loose sandy soil. So that's actually the engineered soil. And so this is what we mean by a sacrificial layer. I can go in there, we can hand excavate all this muck that sits on top of the engineered soil, put some new mulch, put some new plants in there, and we got the system working again. And so that's really one good reason about mulch is that it should clog. We want it to be the sacrificial layer so that we don't end up compromising the infiltration rate of our engineered soil. And when it comes to maintenance, it's always good to at least know that if you do have someone doing maintenance, make them know the difference between engineered soil and just clogged soil or clay soil or whatever kind of sediment that deposits on top. And generally, if you can take grab a soil sample and you ball it up and it stays like a ball in your fist, that's generally going to be clogged. So it's going to have some type of clay or sediment in there that's causing that soil to bind up. Well, most of the time when we use engineered soil, it's going to be loose. For instance, this blend over here on the left is about 90% sand, 10% organics, but it'll be loose. It'll drain. So that's kind of the difference you'll see in most of these designs. And then another good example of using a vegetative system for a multifunctional design. So here you go. This is a subdivision that instead of doing large detention pond to detain all of its stormwater runoff, they incorporated it's pretty much still a large basin, but it's a bioretention basin. So at the bottom of the basin where I highlighted those 2 square areas, that's actually our filtration bed. So that's actually where the engineered soil system sits. And so that system's designed to drain at a certain rate, and that's how you achieve your surface volume. And we'll talk about this in the next webinar, this case study, but this is a really good example where you don't have to do your traditional design of a pond stuck in the back of the lot. You can take your stormwater feature and put it, like for this example, they put it in between the road so that when you come out of your house, you, instead of seeing your neighbor across the road, you see a large green amenity. And it can also serve as a recreational feature. And this project, we'll talk about it more next week, but what's interesting about it is it actually went through Hurricane Harvey. So we put it through the ringer. And just to show you how, how efficient some of these engineered soil systems can be, here's what the bioretention basin looked like during construction. So it's pretty large, and you can see the size of this hole is maybe 100, 150 square feet, and there's 2 of these. So you can see the pipe at the bottom. So these are the 2 drain plugs, if you will, that sit at the bottom of the basin. And so, and you can see there's the engineered soil getting installed. And And just to show you, this is what the bioretention basin looks like during a rain event. I believe what Harvey was, what, 50 plus inches over a 4-day span. And you can see the water level got pretty high. Of course, you get your overflow structure there. But you can kind of see that the value of these can be used as detention features. So in this situation, it looks more like a linear detention pond. But then when it's dry, you got this really nice, luscious landscape that you can use as an amenity and a recreational feature. All right, let's go. We got some questions real quick. See, is your general expectation that the sacrificial layer will have to be periodically removed and replaced? Yes, so I'll talk later on, but we usually remove and replace that mulch layer once a year, maybe twice a year. And we got another good question. What depth of ponding is allowed in this bioretention basin? So typically, you're going to see 1 foot of ponding. I know in certain municipalities, like in Harris County and Houston, you can go up to like 3 or 4 feet. But yeah, that's pretty much your limit, is probably 3 feet. And then what can local municipalities do when there are no compliance requirements or no post-construction ordinance and the bioswale needs maintenance? Really, that's going to come down to the owner. If there's no one really enforcing maintenance, then your system will pretty much, it'll probably sediment in and it'll probably work for a while, but just depending on the design, it's only going to last so long without, you're going to need some type of maintenance. And so anytime you do these designs, it's always good to, what you can do is put a maintenance contract built in so that after it's installed, the contractor has to maintain it for, say the first 3 or 5 years, whatever it may be. But it's always good to also minimize your maintenance. So you can put a design in that's a very minimal maintenance so that your owner doesn't have to worry about it as much. All right, so we're going to go on to this next slide. So this is, you see at the very top, this is a formula that a lot of municipalities will use to size your bioretention or we call it your filtration bed footprint, but really it's just the footprint of your engineered soil. And really what this is a static model. So if you look at the top, it's taking your water quality volume, it's multiplying it by the depth of your filtration bed. And then at the bottom, that's your conductivity rate or your flow rate. So that's how fast that soil can drain. And it also has the time. So this situation, they're assuming it takes 2 days for this basin to drain. The problem with this method is it's static, right? So it's assuming that your whole bioretention or rain garden fills up with water first, and then it starts draining. And when you do that, when you use this sizing method, it ends up oversizing it. So you can see here with this 5-acre lot, they want to have a bioretention bed that's 20,000 square feet, right? It's a very large, or 18,000 square feet. It's a large footprint. So they can up your construction cost, up your maintenance cost. And so what we like to do, instead of using this model where we fill up our rain garden and then let it drain, what we like to do is more of a dynamic model. So this is a TR55 model. So it's a very simple rainfall distribution model. And what it assumes is as your rain garden or your bioretention basin, as it rains, the system's already infiltrating. So that rain garden or bioretention can handle so much rain. And then at the point where the soils are flowing at their peak rate, that's when you actually get your surface storage, right? So then the basin fills up with water. And if it's a really heavy event, you might get some bypass that goes in your overflow. But after the storm calms down, eventually that engineered soil will drain out that entire basin. And when you use this method, you get a more efficient design. So here's a good example visually of how you do that. So in this example, if you look at the top left, you have the same drainage area in all 3 examples, but you have different storage requirements. So in the one on the top, you have plenty of room to store water and your filter bed's pretty small, right? Then if you look at the middle, if you cut down your surface storage, well, then we need to increase our filtration bed so that we can drain it out in the same amount of time. And then if you get to the point where you really don't have a lot of room for surface storage, then at those times, a lot of times your whole vegetation footprint needs to be that engineered soil or filtration bed. And so this is really advantageous for designers because what they can do is they can leverage the size of their bioretention system based off of how much surface storage they have. And so that can make it a little more easy to design these systems. And if we take that same example and we swap out a higher flow rate. So in that first example, it was 1/2 inch an hour. In this example, we're upping it to 100 inches an hour. And what that does is that dramatically reduces your footprint. So we went from 18,000 square feet down to 300 square feet. So we would still maybe have a basin that's, you know, fairly large, but the component that actually does all the drainage needs to be much smaller. So it cuts down construction costs, and it also cuts down on your maintenance. And then you can also run these numbers through a TR55 spreadsheet, just so you can ensure that all the water goes through your filtration bed and doesn't go into bypass mode. And another good example of these types of systems is taking your subsurface drainage. So a lot of times they'll use aggregate wrapped with, and then they'll have a perforated pipe and they'll wrap it with filter fabric. But you know, aggregate only has a 40% storage volume. And so if you take a modular under drain or some other type of arch chamber, whatever it may be, you can actually increase that storage volume. So here's an example. So instead of just using a perforated pipe, we use a tall modular under drain. So each of those boxes can contain 4 cubic feet. So we went from 40% void up to about 90% void. And so, so you can see here's an example where we were installing a bioretention system on a center median swell. And you can see there on the left, they're cutting away the filter cloth. We're putting another microgrid on top. And then, so basically those boxes, so there's about 10 or 12 of those boxes. So we have at least 40 to 50 cubic feet of storage just within the drainage structure, and then not including the voids of the backfill. So here's a better example of how you can expand that to where, say you have a sloped bioretention basin, you can take that under drain, expand it out, whether it's these modular boxes or arch chambers, whatever it may be. And here's an example. It's a recent project we installed out in West Texas. So this system, I believe, is about 2,500 cubic feet. And then we ended up just installing a small 100, 150 square feet bioretention system on top. So you can see we built up these forms. We installed our bridging stone and our engineered soil. And we ended up, they ended up backfilling the top of the tank and all the perimeter with rock. So this is going to be a giant, basically an infiltration basin. And so that's another advantage of using these systems is that you can get more, if you can't get surface storage, you can always store water below by expanding that under drain. And another thing that we like to do in these designs is we like to use a lot of quality assurance. So when we install it, we like to put all of our engineered soil in super sacks. We also, instead of wrapping our under drain in what we call like a filter cloth or a non-woven, we use a microgrid. And so a microgrid is essentially looks like a window tint, or not window tint, like a window screen. So what it does is it keeps the aggregate from getting inside your under drain, but it also allows a higher flow rate. So you don't have to worry about clogging as much. And you can see when we dump that engineered soil in, typically we do about a cubic yard per sack. And it's not too expensive to do this because a lot of times we're only using maybe 10 or 15 bags. So we can fit all that on a truckload. And if you don't know anything about bridging stone, as I said that term before, bridging stone is essentially, and in our design, in our product that we use pea gravel, but all it really does is it provides a layer. So basically what you can do is you install your under drain, you backfill with bridging stone, and then you put your engineered soil on top. So what happens is that engineered soil creates a bridge. So what it does is instead of having to separate the stone and the engineered soil with a filter cloth, you're just using a natural geotechnical process to do the work. And this is a pretty simple method you could do. You can have a geotech do that for you. And then you can also follow, there's a lot of local municipalities that end up using this. And another thing we do is after construction, we will wrap up the system. So after we install the engineered soil, you can see there's a lot of loose dirt, and we'll end up wrapping it up. And A lot of times they'll end up getting a lot of sediment on top. So when we come back to do the planting, we'll have to remove that filter cloth, put in our mulch, and end up doing the planting. And then you can always include this, we call it a SWIP detail, but you can include this detail in your SWIP plan so that the contractor ensures that they do it. So if they have that detail in there, they'll more likely put it in their budget and install it correctly. And then you can always do a infiltration test. So one thing we do is when you do specify engineered soil, if you have a flow rate of say 50 inches an hour or 30 or whatever it may be, you can do a simple flow rate test. So we have a little hydraulic conductivity tester we take out. And this is just keeps the contractor honest, and it also makes sure that after you install it, it wasn't clogged from construction sediment or erosion. And then if the contractor can't pass it, then they have to go back and install it correctly or make repairs. And then probably another common issue you see with these is the overflow structures will get clogged. You know, you're going to have plant debris and matter in there. But what we like to do is, you'll see later on, we like to use beehive overflows or an elevated overflow. Those flat grates will accumulate debris a lot quicker than say a beehive overflow. And then, like I said earlier, erosion's your #1 killer of these systems. Whenever you get these rills develop in the slopes, it just washes all kinds of sediment into your system, and it can really reduce the performance. So that's something to watch out for. You'll see this usually early on when they're trying to establish vegetation. And here's just a good example. This is a project in North Texas where right after its installation, this looks perfect, right? You can't get any better than this. You got your curb cuts on the left, you got some rock there to help dissipate the flow, and then the plant's there to capture all the runoff. But you know, 5 years later, if you don't maintain it, it can look something like this. So it's always crucial to, when you do use these energy dissipation methods, is to really keep that sediment from clogging all the joints. You can see there's actually vegetation growing in the voids of the rock. And so that could be an issue, because now you're just either you're going to have ponding water in the parking lot. So you can kind of see what's happening here is those curb cuts are getting blocked. So now water's ponding in that parking stall, and it's just accumulating sediment, and it's not getting into the vegetation to let it infiltrate. You can also do forebays, structures like that. I'm not a big fan of just these concrete forebays, especially the open ones, because typically if you don't have if it didn't have a lot of free drainage, like if you can't let if your landscape isn't below where the water comes out of these inverts or these structures, you'll end up getting ponding water and a lot of muck and debris. So you can also just, if you want to, you can just do like a rock forebay. But if you don't have some type of structure, especially in a parking lot, you know, if it's an area that's not going to get a lot of sediment, it's not that big of a deal. But an area like this where you have a lot of people walking around, a lot of cars, you can see here what happens when the sediment ends up dropping out of the water. Whenever it stores, it all fills up in the rock void. So this could be challenged to maintain. You know, you might have to like literally dig out the rock and throw it away and get some new rock in there. So what we like to use are these forebay structures. So when you do have a lot of high sediment load coming off a parking lot, you can use an enclosed structure like this. This one actually has a baffle and a screen. So it keeps all the trash and debris in one location, and then it allows that water to trickle out into your swell. And you can see there's the beehive overflow in this swell. So those are the ones that we like to use. All right, so I got some questions. Here we go. So removing or replacing the mulch layer once or twice a year, then replanting is very expensive. So the mulch is not expensive. You can buy a bag of mulch for 25 bucks, and that's like a cubic yard of mulch will go pretty far. Now, typically we don't have to replant them, but yeah, if you do have to replant, that can be expensive, but a lot of times the plants will survive. It's just the mulch that we end up doing. And if you do have a high water table, that can be a challenge. Generally what happens is the groundwater will just drain into the under drain and out into the storm drain. So if you don't want that to occur, you can always line these systems with an impermeable liner. So that'll keep the groundwater from interfering with your engineered soil system. And how does the water eventually leave the storage structure? So yeah, we'll usually tie these into storm drains if we're not infiltrating. So usually we have a filter cloth that's permeable, but most of the time the water just will fill up, drain into the substructure, and then end up going down into the storm drain. Yes, those were drip irrigation lines we saw in those beds. So they tried to cover them up, but I guess for the reason they ended up getting covered up. All right, so we'll move on. So here's another. So that last example was an enclosed structure. So if your owner doesn't want to see trash and debris in the rain garden or in your structure, you can have it enclosed. This one is actually kind of an open top. So you'll actually see trash and debris accumulate, which could be good because that's, it lets the maintenance guys know, hey, this needs to be maintained. But these types of structures are really nice. So this one in particular, it takes water off the surface, drops it down 10 inches, and then it lets it drain into your rain garden or bioretention. So this is another good way of keeping that water in there. All right, cool. We got enough time. We'll go through some of these case studies. So a lot of these case studies are from North Texas and in Houston. There's a lot of, it's pretty popular there where we're using these multifunctional designs. But a lot of these principles can be applied in all parts of the United States. So here's just a really good example of a simple center median swell. And if you look right next to the overflow structure, that's where our bioretention system is. So where you see, I'm not sure what the plant is, I don't know if that's Gulf Muley or Mexican feathergrass, but where those plants are, that's actually where our filtration bed is. That's our engineered soil, our under drain, and all those things. You can see that they never actually took off the straw water from the overflow structure. So it's actually working out well. It's actually keeping some of the debris out of the overflow. And you can see the maintenance is pretty minimal. I'm sure the city, all they've really done is mowed. You can see there's a few pieces of paper that get in there, but this is also a pretty small drainage area and this road isn't used very often. So this was a good pilot project for the city because they knew there wasn't going to be a lot of sediment and debris getting into the swell. So this was a good way for them to apply this concept and test it out. And what they did was they used a rock forebay, basically, where you have these curb cuts. They just had like maybe a foot or 2 foot of this large stone. But you can see even after a couple of years, those things will fill up. So the challenge with these is once they fill up with dirt and debris, you'll start getting vegetation growing in there. And generally it'll hold up pretty well, but if you do want that fresh rock look, you're gonna have to go out there and clean it out. And you can see where a larger curb cut is, how much sediment starts to accumulate in these systems. And so one thing I probably would have improved on this design is you can kind of see where the ditch line is on the swell. I probably would have lined all of that with some type of aggregate. That way it kind of carries that water quicker to the bioretention system. And it also, you can see the grass is having a little more harder time surviving down in that ditch line. So that's one of the ways that you can approve that. And here we go, we got a good question. So it looks like the grass might migrate into the bioretention and take over. Yes, that is a very good probability when you don't maintain those systems. But the good thing is those systems will still infiltrate even with grass on it. It'll reduce the infiltration rate, but it won't completely stop it from draining. And if you do want to remove it, you can always just dig up that grass, put down some mulch, and then replant it. So yeah, those are some of the ways you can do it. And we do have a question about cold winter environment. These systems work great in cold winter. In fact, if you want to email me, I can hook you up with a colleague of mine. They do a lot of work in Maine. And some of these systems will be completely inundated with snow and plowed snow. And then during the summer, they'll do a little bit of maintenance and get it working again. So if you do want to email me or reach out to Becky and get my contact info, I can hook you up with one of my colleagues that comes with that issue a lot. So earlier I talked about the urban heat island effect, right? So we all know that trees do not do well in urban environments, mainly for the fact that sometimes the soil conditions aren't great, but a lot of it has to do with the fact that all the pavement around the trees has compacted the soil so much, it makes it difficult for those tree roots to find the nutrients, the air, and the water that they need. So a lot of times you'll see, especially down where I live in New Orleans, you see the root systems just take over and they will buckle pavement and cause havoc on your utilities. So the answer to that is what we call structural soil cells. So this is a project where you can see here they planted all the trees, but those are actually permeable pavers on the sidewalk side. And then underneath all those permeable pavers sits these Stratavault soil cells. So there's about 3 or 4 different vendors that I've seen with this product, but essentially all it's doing is the soil cells provide structural support for your pavement. You can drive on it, do whatever you need, but the soil that stays within those cells is uncompacted, and you can also put a better blend of soil than just what you dug up out of the ground. And what's really good here, you see this in this design, we got our permeable pavers on top, we got our bedding layer, we got our stone, we got our soil cells, and then below we have a drainage layer. We have our perforated pipe. So essentially what they're trying to do, the design intent was to capture any kind of surface runoff, let it filter through the permeable pavers, let it hit the soil, and so the trees can actually absorb some of that water. And then whatever water doesn't get absorbed can then drain into the subsurface drainage. And so what this does is it feeds the trees, right? You don't have to water the trees as much, but also it provides better subsurface drainage. So maybe you don't have to use such a large pipe system because the voids within that soil cell matrix is pretty high. So you can actually store quite a bit of water just in those tree pits. And here's this example. This is what it looked like during construction. And so, and they're pretty simple to install. These look like little tabletops. You can stack them as high as you want, and then you fill it with soil, and then you'll come back later on and you'll plant the trees. And so this works out pretty good, especially on roadway projects. And we also do a lot of these on big park projects, but this is one instance where the trees actually participate in the stormwater management design. And so, and when it comes to urban heat island effect, we know that these trees are going to do a lot better because now they have more soil, they're going to have more water, and so they'll actually reach their full maturity. So if you have a tree that actually reaches its full maturity, especially in the size of its canopy, well, if it has a larger tree canopy, it's going to capture more rainfall, and then B, it's also going to cast more shade on your site. So that'll really help people, especially this is in North Texas where we get 100-degree days during the summer. So the city wanted a shaded pathway so these pedestrians could go and visit all these different types of businesses. All right, so we got some more questions here. So we got one out of Austin. So in Austin, they fear of the level of maintenance required as a major inhibitor to allowing distributed low impact development and green infrastructure. So what can you say about the reasonableness or not of the maintenance requirements the city should fear? Really, I think if a city puts some type of onus on the contractor or the owner has to turn in a maintenance permit or renew a maintenance permit every year, that's really the only way a municipality can ensure that whatever features that they want them to install are going to be maintained. In fact, they do have that in Austin where they do, they'll send out a violation if you don't renew your permit. But the one challenge that they haven't addressed is they don't go out and enforce it. So unless someone's coming knocking on your door, giving you a call saying, hey, if you don't do this, you're gonna get a fine or whatever it may be, then you basically have to make sure that the cost of compliance is cheaper than the actual violation. And we have another question. Is there any course of tutorial available on how to model these types of devices? Yeah, if you want, you can reach out to me. And we can do it over a webinar, or we can do it over the phone. So if you do want to learn how to model these types of systems, I'd be more than happy to help you out. And do you have a problem with large tap roots? Not really sure how to answer that. Maybe I'll come back to that one. And let's get on with a few more before we get to the questions. So this is a really cool park project we did in North Texas. So what's interesting about this was in the original design, they called for a 6-inch drop off the pavement. And when the contractor installed the landscape, they actually had the landscape go directly up against the pavement. So they had to come back in and cut it down. But they got some really cool results out of this. So you go out and look at this project, it's really great. All you see are these large bioswales that end up draining into a bioretention system on the low side. And what's really cool here is you really don't see any drainage inlets, right? All the water flows into this landscape, and then the landscape takes care of a lot of the infiltration and the drainage. And then there's some small overflow structures that are there for during big rain events. And you can see early on, it took a little bit to get the vegetation established. This is probably where you want to do, more upkeep and more inspection. And you can see we're getting some mulch starting to migrate. And even during the rain event, before all the plants kind of grew up, what happened is it kind of carried some water and sediment down to where our engineered soil filtration footprint is. You can see now this is during a rain event, so it's going to pond water, but there's also some sediment that's gotten into it, but overall it's performed really great. And in fact, the only really maintenance that the parks department here did is they just kept adding mulch. So earlier I was talking about it's always good to remove that clog mulch and put it back and put back a fresh layer. In this situation, they just kept adding mulch. So I think right now they have a foot of mulch sitting on the engineered soil, but it still drains, so it still works. And so this was a good example of having some type of resilience in your design. We'll skip this one. And we'll go to this north. It'll be our last case study. So here's an example where we use this large bioretention basin for detention and water quality. And so this is during construction. You can see we actually wrapped up the gabion walls. So each of these bioretention systems have a gabion wall around it. That's the inspection port you see sticking straight up. Those end up getting cut down. This is what it looked like shortly after they got everything vegetated. And the lesson learned here is, the owner and the contractor kind of went a cheaper method to get it vegetated. They just used this Curlex blanket. As you can see here, these are mostly weeds growing in here. There's not really a good stand of vegetation. There's a lot of bare soil. And if you know anything about Curlex, this is not how you apply it. So they actually just kind of draped it over the weeds. I think the way you apply it is you actually smooth out, you grade out the ground, and then you apply it directly on the surface. And they also wanted some type of vegetation in there because they couldn't get it to grow. So they ended up putting in sod. And when they put sod around the gabion walls, they actually raised up the surface a little bit. So now the water actually ponds in between the bioretention areas. So they had to come back in there and put some fill soil in the middle so that the water could actually get into the gabions and get into these filtration beds. And so when you are gonna have to establish a quick stand of vegetation, what's really great is using hydraulically applied erosion control blankets. So this is a product called Flexterra, where you can put whatever seed blend you want in there. They put in some liquid and they put in the other nutrients that you need, and you literally just spray it out of the end of a hose. And so what this does is you can establish a vegetation within a week or two versus months. So obviously Curlex and these other erosion methods are cheaper, but if you really want to make sure you don't have those erosion problems, spending the extra money for this types of stuff works well. And then lastly, if you guys want to reach out to me, I would love to share you the Harris County Roadway Development. They actually put some really good lid details together on how to apply these vegetated systems for roadway projects, which can also be used for parking lots and other applications. And so this is an open source material. And so they have different design criteria. They have a really nice spreadsheet calculator that allows you to manipulate the size of your bioswale, bioretention, whatever you want to do with it. And then in this example, you can see where they have these berms that kind of help store water. And so this is another good resource that I think you should, if you're really wanting to apply this design concept, this is another good resource that'll help you take advantage of this multifunctional design. And you can see they have the side swells, the center median swells, pretty much any type of application you're going to do on a roadway project. But like I said, this works, for a normal parking lot on a retail area or things like that. All right, so we'll get down to the rest of the questions here. So if you keep adding mulch, will that reduce the ponding requirements? Yes, obviously if you start to raise the surface of your bottom area, it's going to affect the ponding volume. So that's why we like to to make sure that they don't just keep adding mulch. Let's see. Do you have any suggestions for smaller cities in Northwest Arkansas trying to encourage lid that is more diverse than just a grass-lined swale? Obviously what you can do is you can actually put a plant requirement in there. So you can say, hey, we want these native plants. We want, say 100 plants for every 1,000 square feet. So yeah, you can definitely put criteria in there where you're encouraging more plants rather than just a grass-lined swale. So that's definitely something you can do. But again, you got to make sure you have the teeth in your ordinance so that the developers and the engineers follow that. All right, so I think that's all the questions. If you guys, there's my email below. It's Kendrick at ecosvs.com. And there's my phone number if you want to give me a shout. So if you have any other questions or would like any of the resources that I showed in here, I'm more than happy to share that with you guys. And then you can also come back, and I believe we'll have this recorded, so you can come back and review it as well. So with that, I will go ahead and stop sharing, and we will pass this on to Eric, and so he can talk to you guys about native plants.
Thank you so much, Anthony. We really appreciate all that. And thanks for all the great questions, everybody. Keep them coming. And if we don't get to your question throughout the presentation, we'll have a little bit of time at the end to help address some of those. Or feel free to email or call us anytime. So.
All right. Is my mic working?
Yes.
Okay. Thank you. All right. Appreciate it, Anthony and Becky. Pleasure to be here representing Craft and Toll. As Becky stated earlier in this presentation, we had designed 3 low-impact development parking lots for the Beaver Watershed Alliance and the Beaver Watershed, and I'll be discussing those projects later on. But first, I wanted to talk to you about how to determine which native plants are going to be appropriate to use for your next LID project. Just a little bit of background on native plants, why they are an ideal choice for low impact development. They are already a part of the local ecology. For the purposes of this presentation, we're going to consider a plant native if it's growing in the region in which it evolved. I realize that's an oversimplified definition. It's a little more complicated than that, but I think that'll work for our purposes here.
Hey, Eric.
Yes, ma'am.
Sorry to interrupt. Do you mind sharing your screen?
Is it not shared?
Not yet.
I'm so sorry. I thought I clicked it. Oh, let's see here. Where am I?
We'll give you a thumbs up when we can see it.
Appreciate that. Okay.
Excellent.
How about this?
All right.
All right. Thank you. Thank you very much. First time on a webinar, so still low in the learning curve here. Yeah, so native plants are already a part of our local ecosystem. They're have been evolving alongside various other species such as hummingbirds, butterflies, moths, other pollinators for thousands of years, and have come to develop relationships with these other species. A lot of species rely on native plant species in order to live and complete their life and reproductive cycles. So in short, native plants are a part of the web of life. So by planting native plants, we can use these to attract other species such as butterflies and moths that might come to lay their eggs on that plant. Then the birds come and pick those caterpillars off the plants to feed to their young, or perhaps get seeds from the plants for their own food. So with the urbanization and development, can create habitat fragmentation, loss of these services for the local ecosystems. So planting native plants is like a way of reweaving the web of life back into the built environment, help patch back in some of the habitat that was lost due to the development and urbanization. Not only that, but using native plants for low impact development projects is just great for species conservation. Like I said earlier, there are some species that are completely dependent upon native plant species in order to complete their life cycles. Case in point, monarch butterflies. They require native plants to sustain them along their migration routes across North America, especially native milkweeds. They need these to lay their eggs and provide nurseries for their growing young. So without these species of native milkweeds along their flyways, they cannot complete their annual migration each year. And a lot of the decline in the number of monarch butterflies that we've seen over the last several years has been attributed to this loss of habitat. What about some other benefits of using native species? Well, one thing to understand is many native species have very deep root systems, and these reach deep down into the soil profile to pull up water during those dry summer months. And this helps them be more drought resistant than many of the non-native landscaping alternatives that have traditionally been used over the last 100 years or so. These deep root systems also help hold the soil in place. They improve the soil's ability to absorb and filter stormwater. This helps reduce runoff and removes more pollutants before they enter our local waterways. Also, since they're already adapted to our local climate, the need to irrigate water and to keep them watered throughout the year is significantly reduced. Now, there may be a need during the first year after a planting to keep them watered to help them get established, but generally once the plants are established, they require very little maintenance and irrigation and can survive mostly on the rain that falls from the sky. They're also adapted to poor, low-quality soils with low levels of nutrients. In fact, adding too many nutrients to a native plant garden can cause what's called lodging. These plants can grow too tall and then fall over. So a reduction in the use of fertilizers is not just a cost-saving mechanism, but also helps reduce the amount of nutrients that are in the runoff entering our local waterways and reduces nutrient pollution. And because they're already adapted to the local ecosystems and the pests that are involved here, we can reduce the amount of pesticides that we're using by using native plants. Many non-native species don't have those adaptations to our local pests that these native species have developed over the millennia. And since many invasive species started off as gardening plants, by using native species, we can help reduce the number of invasive species that we're allowing to escape our gardens and get into the ecosystem. So what about some planning and design considerations? If you want to use native plants in your next project, what sort of factors do you need to consider when determining which species are going to work and which ones will not? And for that, we're going to look to nature. We're going to note the environmental conditions of the location where we see the species growing naturally in the wild. Where do these species like to grow? What is the soil moisture where we see them growing? Is it very wet, very dry? What's about the soil pH, sunlight duration? Is it in full sun, part shade, full shade? As far as soil moisture goes, there is a list, wetland plant list maintained by the U.S. Army Corps of Engineers. They have a list for each state and also the various different regions they've divided the country into. I have a picture here of the first page of the Arkansas's wetland plant list. Another place you can get this information is plants.usda.gov. If you type in a species, and here I've given an example of white oak, Quercus alba, it will pull up a profile for that species. And you'll see here in the red box, if you click on the wetland tab, it will then bring you to this, which will list the wetland indicator status for that species in each of the regions that the Corps has divided North America into. Here in Arkansas, this part of Arkansas, the Ozarks, we're in the Eastern Mountains and Piedmont. Southern and Eastern Arkansas are in the Atlantic and Gulf Coastal Plain. And if you're listening from a different part of the country, you'll need to look up what region your part of the country is located within. But here is a map of the Eastern Mountain and Piedmont region. As you can see, it does cover a lot of the Eastern United States and then the interior highlands of Missouri and Arkansas. So what are the different wetland indicator statuses? Have them listed here. UPL stands for upland. These are going to be plants that prefer well-drained soil. They can't handle inundation or much moisture. They are typically found high on the landscape in areas where ponding typically will not occur. On the other end of the spectrum are OBL, or obligate wetland plants. These are going to be the ones that really like having wet roots. These are going to be your buttonbush, your cattails, a lot of the plants that we typically associate with, swamps and wetland type areas. In the middle there is facultative, FAC. These plants are going to like moderately dry to moderately wet conditions. And then in between each of those, you have facultative wet and facultative upland, and these are going to be kind of the halfway points in between facultative and the upland and obligate statuses. So if you kind of think of this as a gradation of plants that like dry conditions to plants that like wet conditions at the bottom, these can generally help you with trying to figure out where on the landscape to place each species. Obligate and facultative wetland species, these are going to be better for low areas on the landscape, poorly drained areas that stay saturated or wet for much of the growing season. So some rain gardens that may be a little lower in the landscape, bioswales, pond edges, edges of streams, where those water levels kind of alternate, go up and down. Facultative species, like I said a minute ago, these like your moderately dry or moderately wet areas. Again, these can go well in rain gardens depending on how much water you're expecting to go through there. Bioswales, maybe some north-facing slopes that don't get a lot of sun depending on where you're located. Here in the Ozarks, our north-facing slopes typically have a lot of mestic forests just because there's not sunlight shining on these slopes in order to cause the evaporation. Also, transition zones between wet and dry soil, a great place for these facultative species. Then facultative upland and upland species. These are going to like areas that are well drained, uplands and hilltops, berms, south and west facing slopes that get a lot of sun, and just well drained soils in general. What about soil pH? Here in our part of the country, a lot of our lower pH soils are going to be found under the pine trees. A lot of pines just aren't great base cyclers, and a lot of the debris that they shed each year contains some acidic components that tends to lower the pH of the soil. When I'm out hiking, I tend to find a lot of species that prefer these low pH areas under these pine groves, such as our wild blueberry species. You can also find low pH soils in areas where the soil's parent material came from either igneous rock, chert, or sandstone. These tend to impart a slightly lower pH to the soil than where the parent material is made of dolomite or limestone, which has a lot more of alkaline or calcareous properties to it. These types of soils are going to be found in mid to late successional forest. Beeches and maples are much better base cyclers than pines. And oaks are also better base cyclers than pines, but not as good as your beeches and maples. So a lot of these later successional forests, you'll see a rise in pH as the forest goes through the different successional stages. So what about sunlight duration? Well, some native plants are going to like full sun. A lot of these plants are going to find in the natural habitats of prairies and glades and areas that don't have a whole lot of things obstructing the sun. You can plant these in wide open areas, or if you're here in the Ozarks or perhaps in Appalachians or somewhere with south-facing slopes to get a lot of sun, that might be a good place for them as well. South side of a house or building. Partial sun, and you're going to find these in their natural habitat, open forests, savannas, forest edges. You'll probably also see a lot of plants that are adapted to prairies and glades that could also handle some partial shade. Same with some forest plants. They might be able to handle a little bit of sun. So this category is a little more ambiguous. But the native plants are full shade. Generally, these are ones that you're going to find in the forest where they're adapted to that canopy and they need that shade in order to complete their life cycle. They can't handle that direct sun. They'll usually burn up. Other design considerations, the bloom period for each species. Is it going to bloom in early spring? Is it going to bloom early to midsummer or late summer, early fall? You might consider that when you're deciding the combination of species to use, or also just where to place it in the landscape. Floral layering, some species are going to be taller than others. So you might keep if you have a rain garden, you might keep the tall ones towards the center of the rain garden, short ones towards the edges, so nothing's being blocked out. Life cycle of the plant, is it an annual versus a biennial versus perennial? The annuals are going to complete their life cycle in 1 year and then reseed themselves. These are generally going to be a little more shifty in their position each year, from year to year. It's really just going to depend a lot on where did the seeds fall and how many of them germinated versus how many of them might have been eaten by birds or wildlife. The perennials, they typically are not going to flower your first year, but if you give them 2, 3, 4 years, you'll be very happy with the native perennials because they do pretty well once you give them a chance. So as far as our 3 low impact development parking lots that we designed, and again, I was not the project manager on this project. I just helped with the native plant selection. Barry Williams, our senior landscape architect, was the project manager. So a lot of the technical questions were related to the design of the rain gardens and whatnot might need to be directed towards him. But I'm happy to answer any questions regarding the native plants that we chose for these projects. So our first low impact development parking lot was at Kessler Mountain Regional Park in Fayetteville, Arkansas. This is the urban park that Becky referred to. Another parking area will be at Hickory Creek Marina, located in Benton County. This is the one that's right on Beaver Lake, our drinking water source. And then Mitchison Park in Huntsville, which is a rural community in Madison County. For each of these sites, we included a seed mix. We wanted to include species that attracted pollinators. We also included species that are great for degrading petroleum that might be contained in the runoff from the parking areas. So here are some of the wildflowers that we decided to include in our seed mix. We have purple coneflower, wild bergamot, black-eyed Susan, partridge pea, plains coreopsis, common sunflower, and then some grasses, some side oats grama, bottlebrush grass, little blue stem, and switchgrass. 3 of these are warm season grasses, and the bottlebrush grass is considered a cool season grass. So I wanted to have a variety there. So Kessler Mountain Regional Park in Fayetteville. Here's a picture showing an overview or an aerial photo of the park, and it's located in Washington County. Here is an aerial photograph with a red box around our project area. So when we zoom into our project area, I have 2 photographs showing the existing conditions with arrows pointing to where these photographs are taken. And here is our drawing design. This is it turned on its side so that we can read the labels with another red box drawn around the rain garden area, which I will be discussing. Okay, so here's the rain garden area. We had 2 different types of site conditions to consider when making our plant selections. The first is the edge of the rain garden. We'll have more well-drained soil and we'll get full sun, considering it's in the middle or towards the center of the regional park. There's not a whole lot obstructing the view there, or the sunlight. The second region is going to be towards the middle or the low spot of the rain garden. The soil here is expected to be much more moist, and again, we still expect this area to get full sun. So what species did we select? Well, we'll start off with what's higher up on the berm. Black gum, we thought that this would provide some wildlife benefits. There are a lot of different bird species and whatnot that like to use black gum as a food source or to build nests in. And you can see it is a facultative species. American beautyberry, a facultative upland species in the Eastern Mountain and Piedmont region. This is also a great plant to attract pollinators and is also a host plant for several different butterfly species in our area. Rattlesnake master, facultative species, another great one for attracting pollinators. A good friend of mine once said that she thought Rattlesnake master sounded like a great name for a heavy metal band, and I agree with that. Indian grass, a facultative upland species. This is also a great one for degrading mild to moderate levels of petroleum contamination in soil. The reason for this is a lot of our big four grasses, the little blue stem, big blue stem, Indian grass, and switchgrass have very fibrous root systems. And really all plants have the ability to degrade petroleum in the rhizospheres of their root systems by stimulating microbial activity, and it's the microbes that actually break down these hydrocarbons. But because a lot of our big grasses here, especially Indian grass, the root systems are so fibrous, they have a lot of surface area. And due to this high amount of surface area, there's a lot of microbial activity that they're stimulating that is breaking down these petroleum products. So that's one reason why we included these, in addition to the fact that some of these big four grasses, such as Indian grass, little blue stem, are also host plants for various pollinators and provide food sources in the wintertime for bird populations. Bald cypress, here's an obligate wetland plant, very beneficial to wildlife. If you've ever been to any of the swamps around here, you've probably seen plenty of bald cypress. Common buttonbush, another obligate wetland plant, and another great plant for attracting pollinators. Has a very pretty white flower. Almost looks like a coronavirus if you kind of look at it, but it is a very beautiful flower. Also, these will turn into some bright red fruits later in the summer. Soft rush, Juncus effusus, facultative wetland species, another great one for degrading petroleum just because of its root system. Cardinal flower, facultative wetland species, attracts pollinators, especially hummingbirds. Hummingbirds love the shape of the flowers because they can stick their long beaks down in there. I've seen a lot of hummingbirds on cardinal flowers around our house. Look at our next parking lot here, Benton County, Arkansas, Hickory Creek Marina. Benton County is the county in the most northwestern corner of our state. So here is a red box showing the marina where our project's located. Zoom in on that, a couple of photographs showing the existing conditions there. And here is the area containing a rain garden and a drainage swell. So we have two different areas with different site conditions we're looking at for this location. First, the rain garden. It's going to be in partial sun. There are some trees around that we expect to provide, to be blocking the sunlight for part of the day there. It's also going to have, we're expecting more moist soil there. Then the drainage swell. It's going to be sloped. We consider that to be pretty well drained, and it's also going. We expect that area to be in full shade. So the rain garden, we chose to plant or to specify cut plant, a facultative species. You see it growing a lot on riparian areas around here. It's also another great one for attracting pollinators. Again, soft rush, another great one for degrading petroleum, as a facultative wetland species, so it can handle that moist area. And again, cardinal flower, facultative wetland species. Northern spice bush, this is going to go along the drainage swell. It's a facultative species, excuse me. You see it growing a lot along riparian areas of streams, north slopes where it stays, reasonably moist, doesn't dry out too bad. And it is the host plant for the spice bush swallowtail butterfly, among other species as well. And traditionally it was used as an allspice substitute. If you can taste or smell the leaves, they don't taste great just to eat by themselves, but it could be used as a seasoning or to make a tea. I enjoyed it. Wood oats, Chasmanthium latifolium, facultative upland species. I really like these because they provide great winter aesthetics. You see these little seed heads on them. those will usually hang around for a lot of the winter. So when everything else is dead and gone, this sticks around, and it just helps provide, I think the aesthetic value with these is really important, because, I mean, public buy-in is really going to be crucial. We're wanting to make sure that the public sees these, likes them, thinks they're pretty, and is inspired to implement similar projects, either in their homes, businesses, or cities. Purple coneflower, Echinacea purpurea, another great one for pollinators, is a butterfly magnet. And our final park, our final parking lot I'm going to go over is at Mitchison Park in Huntsville, which is located in Madison County. Here is an aerial photograph of Mitchison Park in a box around the section where our project is located. Here's a closer up view of our project location with 2 photos showing the existing conditions. At the bottom photograph, you can see the existing parking area. And just beyond that, you'll see a slope, which is shown in the top photograph. And so here's the design with a box focusing around the drainage swell that we designed. And for this, we just had one site condition. It was a sloped or well-drained area located in full sun. So again, we chose rattlesnake master. Facultative species, attracts pollinators. Purple coneflower, which does not have a wetland indicator status, and generally when they don't, you just assume it's an upland plant. But these are also, like I mentioned, great for butterflies. American beautyberry, mentioned it earlier, another great one for pollinators. Fragrant sumac, another great pollinator plant, produces these really pretty fuzzy red clusters of berries. Gay feather, also known as prairie blazing star, very beautiful purple flower. And butterfly milkweed, attracts pollinators and is essential for monarch butterflies and many other butterfly species. Okay, with that, I'm going to take a few questions here. Let's see if I can see. Do we have any? Is wood oats the same as inland sea oats? Yes, yes. Chasmanthian latifolium, those are the same species. I just always feel a little weird being in northern Arkansas calling them inland sea oats, and I always see them in the woods, so I've been usually calling them wood oats. How much maintenance will the Kessler project need? And that's probably a good question for our engineers and landscape architects. Let me go back and see if I can. It's pretty far back there. I mean, our hope is that it's going to be low maintenance. That's one reason why we were putting the seed mix in there too, is to help compete with any non-native or invasive vegetation that might try to get in there. And we'll also have some, I'm sure, some compost down like Anthony had suggested. Do you do any pre-treatment of your seed mixes? That's going to be up to where we get our seed mix from. Most places don't. At least the places I've talked to. So it's a lot of it is the method you're going to, I mean, I really recommend seeding in late fall, early winter, and then covering it with just a very light layer of straw. Down here, this far south, we have enough warmer days in the wintertime when those seeds will go ahead and germinate, and it gives them a head start. So that way, by the time spring comes and the growing season is in full swing, these plants seem to do much better. Up north, that might not be an issue where it's going to stay frozen all winter long. But yeah, you do want to make sure, depending on the species, some will need some form of stratification. Some species require cold stratification that mimics the process that the seed goes through when it's laying on the ground throughout the wintertime. And sometimes if you just plant in the late fall or winter, then that can help that process occur. The issue there is you got to keep the birds from eating them. It helps with a little bit of cover. I'm sure there's also plenty of engineered materials that can help protect the seeds until they germinate as well. And Anthony might be able to answer more questions regarding that. Let's see, it appears it's all predicated on being in a climate zone where the rains will be frequent, so the lower portions of the rain garden will always be wet. Have you dealt with situations where the whole bed will dry out for long periods? I personally don't have direct experience with that. I mean, we're in a we get pretty wet here in Arkansas. I would recommend, though, if you're going to have a dry bed, you might just, make sure you're choosing species that are going to, either be facultative upland, or upland species. Steve Allred mentioned some plant suppliers. There's a really great resource guide put out by Grow Native that has a list of everything from growers to seed producers to landscape architects to whatnot. That'll, I think you may have to pay for that, or you can check it out on their website. Ernst Conservation Seeds, they produce some local ecotypes that you can go for, but one thing you want to make sure of is when you're getting your seeds or your plants that you're sourcing them from locations as close to your project site as possible, just so that they are adapted to the environmental conditions that are at your project site. If you get them from too far away, then you might have some plants that aren't adapted either to our frost dates or amount of rain that we may get in that area. In the area where no plants are shown, bare mulch. I know we're putting the seed mix in that area too, so it probably will be mulched at first, but we're intending for it to be filled in with vegetation. Oh yes, Felicia, thank you. Steve, you can find the resource guide at grownative.org. And what percentage coverage do you see inside the bioretention area? I'm hoping full coverage. We'll see. It might require some maintenance and some follow-up to make sure that happens. I've seen that many beds will stay dry for extended periods. Yeah, that is true. I mean, a well-designed rain garden will drain within 48 hours. Sometimes, though, if you have a network of bioretention cells for stormwater, that you may consider, well, which cell is that water flowing into first versus last. That first one's going to dry out much quicker than that last one. And you would have to estimate the amount of water you're expecting to be in there to know how moist is that soil going to stay throughout the growing season to know what species to put in there. Can you go over how to search by region? I'm assuming you're asking about the wetland indicator status. So let me go back to that slide here. So if you go to plants.usda.gov, you can type in a species and it'll give you the wetland indicator status for that species for each of the regions. However, if you want to go to, and I have the website right here, wetland-plants.usace.army.mil, you can download the list by region, and it'll include the wetland indicator status for every plant that they think is in that region. Now, I'll put a caveat that sometimes you'll find species that aren't on the list that might be in another region, and that's fine if it's close enough. Yeah, but here you can either download lists by state, by region, as either a PDF or even an Excel file. So if you're wanting an Excel file just for be able to copy paste stuff, that's pretty handy there too. Let's see, what are some good sources of native plants if you don't have a local nursery? Somebody answered that. Yeah, there is Prairie Nursery. I would really look in your region too. You can usually do a Google search. I mean, I think if it's within a 50-mile radius, that's okay. A 100-mile radius isn't ideal, but you know, it's sometimes you just got to go with what's available. Have you used a hydro seeders to apply diverse native seed mixes? Is it effective? I want to know that. I have not, and that's something I'm very interested in because I would really like to see more native seed mixes being used in those hydro seeders, especially for highway projects and transportation and whatnot.
Hey, Eric, I can speak to that. And yes, it is very effective. And one thing that we do is we work with a really cool vendor called Profile. So what we'll do is we'll go take a sample of the soil before we hydroseed it, and they'll test it for us. They'll let us know if we need to add any additional nutrients like nitrogen and phosphorus to the hydroseed mix. And then we'll take whatever seed mix is specified, mix it all in, and you can get much more comprehensive and effective vegetation, and it'll be more consistent, so you don't have to worry about these patchy areas. But it does require that you make sure that you know, the area is graded out, you don't have a lot of ruts, because you want to make sure that it's all applied correctly. But yes, it is a very effective method.
All right, thank you, Anthony. And with that, I don't know if I'm seeing any other new questions. So I will probably stop sharing my screen at this point and hand it back over to Becky.
Awesome. Thanks, Eric. Okay, one more thing to share with y'all before we wrap up today. Let's see here. We do want to thank both Anthony and Eric for your presentations today. We hope that everybody was able to find this information useful and for your next low impact development project. So, that today wraps up our number 2 of this online series. We'd like to invite you to come back next week, Wednesday, May 20th at 10 a.m. We're going to talk about where have all the ditches gone, the value of bioswales as stormwater detention features. Again, you can register through beaverwatershedalliance.org. It's on our calendar. You can find us on Facebook, and we're also posting these to our different media channels. So with that, we just want to thank everybody for coming today. We're going to hang out here for just a few minutes in case there's any last minute questions. Otherwise, we'll see you next week, or let us know. Oh, we have a few raised hands. Let us know how we can help with your LID projects or any questions you have. So thanks so much for y'all coming today. We're going to answer some of these last minute questions here.
Hey, Becky, are you going to be sending out a link to the video, or how will that be done?
Yes, so we're going to do a follow-up email to everybody that's going to have a link to today's webinar. And we're also going to be posting the links for all 3 of these series, either on our website or YouTube channel. So more on that to come. All right, and okay.
Jonathan is asking about any books or resources he'd recommend. And Jonathan, I have your email. I'm more than happy to send you a list. And anyone else too, feel free to get a hold of me. But I'm
See, Ron, did you have a question? All right.
So someone's asking about building a berm in your backyard. So what I recommend, if you do build a berm, maybe have a good structural base like rock or some type of aggregate. And then if you're going to use any type of fill material on top to form the top, you could either use sand or any other type of soil that is compactable. So one way you can do it is you can rent one of those plate compactors from like Home Depot or somewhere, or you can hand tamper it down. And basically you just want to make sure that it's all compacted together as much as you can. And then when it comes to vegetation, yeah, you could use jute matting or some other type of erosion blanket on top of it. And so if it's pretty small like that, and then you can do some type of topsoil with a native seed plant. But I'm not for sure which plant will be the best though. That would probably be more of an Eric question.
I'm trying to understand what you're getting at by semi-invisible. I mean, I would recommend if you're going to put some jute matting down, I know when I've worked with that before, we put stakes. We know this might not work as well in a berm, but we were using willow stakes and whatnot. I would think maybe some woody vegetation, depending on how large the holes in the jute matting is, it may prevent herbaceous vegetation from coming through there.
Oh, I think he's talking about the jute matting becoming semi-invisible so that you can't see the jute mat through the vegetation.
I see. So something that produces a lot of foliage to cover it up is probably what he's getting at. I mean, switchgrass produces a lot of biomass, a lot of foliage. That might be a good one. It also is great for taking up nitrogen, excess nutrients. So it's, you know, if you have a local stream or waterway, any fertilizer being applied would be reduced before it could enter that if it's filtered through that switchgrass first. But then again, the region you're living in, I don't know what the indicator status is for switchgrass. So you might want to look at that and make sure it can handle a berm type situation.
Okay, any other questions we want to address at the moment, or if not, again, we want to thank everybody for coming today, and please do reach out. Hope you all have a great rest of your day, and we'll be here next week. Thanks.